Hello dear students and welcome to Vistaslearning, an online educational platform. My name is Denzil. I'll be your physics tutor for class 11. Now let's get started with the first chapter since we've already dealt with an introduction to class 11. Now the first chapter that we'll be discussing is based on physical world. So this would just be an introduction session of the chapter, session 1 of the chapter Physical World. This is currently a live session. So those of you out there, let me do a quick audio and video test. So I want your assistance. I want you to give me a thumbs up if I'm audible as well as visible to you. So let's make a quick audio test. Am I audible? Visible? All good, all set, excellent. So let's get started. The beauty of nature. We fascinate looking up the beauty, especially up in the skies, the stars, the night skies. When you look up, you find that the awe of nature, it fascinates people because there's so much of mysteries that lies behind it. Now, some of the mysteries have been unraveled to us, but there are a lot many which remains hidden. Now, especially when I was teaching for younger kids, there was a student of class 7 standard who walked up to me and asked me a question. He said, "Sir, imagine you're standing on top of a mountain and then you witness the sun rising and sun setting. From this, you can infer that Earth is rotating. Therefore, you see sun rise, sunset, and after sunset, you see the stars that rise and stars that set." I said, assume that you're same on top of that same mountain, but this time there is no sun, there is no stars, there are no heavenly objects. How will you know if Earth is rotating? What an interesting question asked by a 7th standard student. So to understand, to answer such question, we rely on a concept, on a subject which is known to us as physics. So we start with an introduction to physical world. So let's get started with the first question as to what is science? Now that you have entered into a mainstream of STEM, which is also called as a science, technology, engineering, and mathematics as a subject, so what exactly is a science? Well, science is a detailed study of natural phenomena. So what are the various natural phenomena that we observe? Here's an example. If I take an object and I let go of it, the object always falls to the ground. It's attracted towards the center of the earth. Why? And that is one of the natural phenomena. So it is a study of natural phenomena, a detailed study of a natural phenomena in a systematic approach. So you notice here that we in science, we conduct a systematic approach so as to use the knowledge gained to predict, modify, and control phenomena. So let's understand what exactly can you predict, modify, and control phenomena. Now that, let's say, we have understood the concept of gravity is quite known to us, it's familiar. Well, not entirely, but to maximum amount of that we know what gravitational force is. Now, what did we predict? Now, the first few predictions which was provided by Johannes Kepler, you might have read them in your class 10, where you have about Johannes Kepler, where he collected the data from Tycho Brahe, his mentor, and then predicted the model of solar system, how Earth revolves around the sun. Modify. Why do we need to modify such theories? Now, we need to modify this because if you need to launch a satellite, which we do currently, the reason why I'm able to communicate to you is because via satellite. And how do we control the phenomena? obviously we have many satellites up there. It is not just one single satellite that is responsible for communication. We have many, which means we don't want one satellite smashing into another satellite. So it has to be controlled. So we use theories as we study the nature, okay, and then we predict, modify, and control them. So what would be the systematic approach to study science? But first of all, let us understand, where did the term science originate from? The term science originates from a Latin word which is called scientia. In India, Sanskrit, the word science is vigna. Scientia is where it originated, but in India we call it vigna. So let us look at few scientific methods that we use in science. So what are the scientific methods used? The first scientific would be, the method used would be a systematic observations. In order to understand a given phenomena that occurs, a natural phenomena, as in the object when it falls to the ground, you make an observation. So what is a systematic observation? If one object falls to the ground, does that mean all the objects fall to the ground? Certainly they do, right? So we will look into few more examples as such, particularly the next section you will see. But first, what other methods? Controlled experiments. So after you make observations, conduct a controlled experiments. Then you qualitatively and quantitatively reason those controlled experiment and the observations that were conducted. Next is to create a mathematical model, predict and verify and falsification of theories. So up to this point where you conduct the whole systematic approach, you have set your theory. So your theory is prepared. But now in science, we have the next method, which is a falsification of theory. So we deliberately try to find that if the given theory is false or not. We deliberately want it to be false. But apparently, if that theory turns out to be true, then we have unraveled one of the physical phenomena. So to approach a systematic approach, so let's take a look at the example here. Iron ball, wooden ball. Which one falls to the ground first? Well, can you answer? Among the two, iron ball and a wooden ball, which one will fall to the ground first? Well, interesting question. Much of a Galileo who says that is impossible. Both the objects fall to the ground at the same time. Galileo Galilei during the 16th century conducted an experiment where he stood on top of a tower, dropped two balls of the same volume, one which is an iron ball, the other is a wooden ball. So among the two, iron and a wooden ball, obviously iron should be a heavier one, right? But when he dropped it from top of a tower, what he noticed is both the ball fall to the ground at the same time. Meaning gravity does not have any such partiality. The gravitational force acts the same on every object. Now here's another picture of a ball and a feather which are dropped. You notice both the objects fall to the ground at the same time. But that does not happen realistically speaking. When you take a hammer and a feather, obviously you see that the hammer drops first. But in this picture, in this animation, you see both the objects fall to the ground at the same time. So why? Well, I'll leave that question to you. You reason out why do both the objects fall to the ground same time, but in case when you try the experiment with hammer and a feather, hammer falls first. So why does that happen? So moving on to the next section. So Galileo only discussed the three sections which were systematic observation. He conducted a systematic observation of objects that fall to the ground. He conducted an experiment where he dropped two balls, one iron and the other wooden ball, to check if both the balls fall to the ground at the same time. Also, he was able to make a qualitative and a quantitative reasoning saying that this object fall to the ground is because of gravity acting the same on every other object. But he was not successfully able to create a mathematical model. So further predictions were hard for Galileo. So this task was later taken up by another famous physicist by the name Sir Isaac Newton. Well, Sir Isaac Newton stated, for an object which falls to the ground under the gravitational force of attraction, the influence of gravitational force of attraction. So when I let go of the apple falls to the ground. Now, as the apple falls to the ground, what you also notice, it changes its speed. This change in speed is what results to called acceleration. Yes, you might have learned this in your class 10, the concept of acceleration, the rate of change of velocity. This was actually, the mathematical model was actually described by Sir Isaac Newton. So there's more concepts that we rely on acceleration. Then you will see there are more problems and interesting ones and also the difficult ones. Don't worry about them. I'll try to make it easy for you. Okay. So now coming to what is physics. Now that we have learned what is science, systematic approach to science, what is physics? Physics is a natural science. In fact, it deals with the study of basic laws of nature and the manifestation in different natural phenomena. Laws of nature. So what are the various laws of nature that you have learned so far? Again, one of the laws of nature that Sir Isaac Newton proposed is what is called the law of gravitation. Law of gravitation, where it states two different objects exert a gravitational force on each other depending on the masses, where product of their masses, and the distance between them, where it is inversely proportional. So the force, gravitational force, is inversely proportional to the square of the distance and product of two masses, m1 and m2. This is quite an interesting theory that was put forward and which later proved to be true by a Cavendish's experiment where he stated, I know how to weigh the earth. Just by using a simple law of gravitation, he was able to determine what is the mass of earth. Right? So the next is to deal with the scope of physics. So what is a scope of physics? So what lies ahead? All right. Now to understand this one, we would do that in the next session, which is session 2 of the chapter Physical World. But kindly log into www.we-learning.in, where you have many more videos that are related to 1st, 11th and 12th standard, which is also 1st and 2nd PU. Various other subjects, you have physics, chemistry, mathematics, biology, electronics, computer science, and lot many other subjects. Kindly share this with your friends and family, because there are people who need assistance with the studies. Since we're providing a quality education for free, why waste them, right? So go ahead, provide it to your friends and family, those who are in need, and then a quick description about further concepts of physics as to what is unification and reduction. So I'll keep this very short for you as to what is a unification and reduction. Now, when a given theory is proposed, now there are two ways that you can propose a given theory. One is where you take two different theories, combine them as one, which is also called a unification. So unification is a unifying of different laws, different phenomena into a single theory that explains different phenomena. So what exactly is two different phenomena that we're dealing with? So there's one example, the laws of electromagnetism. The law of electromagnetism deals with two different entities, one which is electricity and the other which is magnetism. Two different theories unified as one single theory called an electromagnetism. This was proposed, the theory was proposed by a famous physicist, Maxwell. James Clerk Maxwell, famous physicist, who unified the two different theories, electricity and magnetism. Similarly, you can also say Sir Isaac Newton was able to unify the earth and heaven. In fact, when we look up during the time of Isaac Newton, heaven was something different that lied above. So we had nothing to do with the heavens above. So whatever was in the heavens above was dealt with God, and whatever was on the earth, it was us for people to just survive. But it was Sir Isaac Newton who actually looked beyond the space. In search of God, he went beyond the space, where he unified the heavens above and the earth here. Okay, so the next is reduction. So a quick description of what is a reduction. It is the effort to solve a complete problem by breaking into simple parts. So let me give you a quick idea of this. Two mugs, one which contains cold water, another which contains hot water. Among the two, which one has more energy? So one cup that contains cold water, okay, so this is cold. Another cup which contains hot water, a little bit of steam, hot. Which one has more energy? Now certainly your answer would be hot. Now the question would be, why does it have more energy? Well, to answer this question, we need to break down the problem. We need to, in fact, look into the molecules itself, what is happening to them. In case of molecules for a hot cup of coffee or a hot cup of water, the water molecules are vibrating very fast. Since they have more vibration, they have more kinetic energy. In case of a cold cup of coffee or cold water, what you see that the molecules are not vibrating very much. Not as much as the hot water at least. So in that case, because of more the kinetic energy of the molecules, you say that the hot cup has more energy. So what did we just do here? We used the concept of reduction, where we took a given problem, we